talk about carboxylic acids. Today we're going to talk about carboxylic acids, which are another class of organic compounds and contain carbonyl group or C double bond O. But if you here pay attention, there is a OH attached to it. To carbonyl group, we have OH directly attached to it. The functional group of the carboxylic acid is a carboxyl group. This is called all together, that is called carboxyl group. This is also written this way or this way. So whenever you see these different formats, they all mean you have a carboxyl group and you have a carboxylic acid structure. Carboxylic acids, we always find the longest chain, which includes the carbonyl group. We start numbering from the carbonyl group. And we have here 1, 2, 3, 4, 5, and 6. So we have 6 carbon, which is hex, right? And we always end with oic acid. It's gonna be hexanoic acid. We do not need, guys, to emphasize on 1 because always in carboxylic acids, we start with carbonyl group with 1. If there are other branches, we added before that. This is carboxylic acid because we have a carbonyl group attached directly to OH. This is carboxylic acid compound. Here we start from carbonyl group for numbering. It's gonna be 1, 2, 3, 4, and this is gonna be our longest chain. Then if we have any substituent, we should write it down before the parent name alphabetically. If there is more than 1, we should write them down alphabetically. So it's gonna be 3-methyl butanoic acid because I have 4 carbon in the longest chain. And we always end with oic acid. So it's going to be 3-methyl butanoic acid. What about this one, guys? Here we have 2 functional groups. One is alcohol and one is carboxylic acid. If you remember from the priority table, this is the carboxylic acid functional group is prior to alcohol functional group. If you look at the priority table, carboxylic acid is higher prior to alcohol. So we should use the parent name of oic acid or based on the carboxylic acid, and my alcohol should be using hydroxy as a prefix because it is not the parent name. If we go back here, we start numbering 1 from carbonyl group because, as I said, this is the prior group. The carboxyl group is a prior group because it's at the top of the table compared to the hydroxy or alcohol group here. So it's going to be 5-hydroxy hexanoic acid. What about this one, guys? Again, if you go back to the table, again, carboxylic acid is prior to amine group. You see, that's the higher priority compared to amine group. So if you go back here, we should name our parent name based on benzoic acid because I have a COH there. So this one will be used as amino. we start numbering 1 from the branch that has a COH in it. 1, 2, 3, 4. So it's going to be 4-amino benzoic acid or para-amino benzoic acid. What about if we have 2 carboxylic acid in a structure? You see here, this is the carboxylic acid because I have a carbonyl directly attached to OH. Then you see the other side, also I have a carbonyl group attached to OH. So I have 2 carboxyl group here. To mention it, we should write, so I have 2 carbon as the longest chain, right? 1, 2, so it's going to be ethane, and I should put di here. So it's going to be ethane dioic acid. That's the common name. Oxalic acid is the common name for it. Here also I have 2 carboxyl group. It doesn't matter from which side I start numbering because they are mirror of each other. So it's going to be 3 carbon. It's going to be propane dioic acid. Malonic acid is the common name for it. Okay, let's talk about carboxyl derivatives. What does it mean? Look at the carboxylic acid. We just talked about it. We have a carbonyl group and there is OH attached to it. That's the carboxylic acid. In another form of the derivatives, when we have anhydride, the oxygen and the carbonyl group are preserved. Look at here, see, compared to the carboxylic acid. This part is preserved, but the hydrogen of carboxylic acid is replaced by another carbonyl group and another carbon. That's the basic form of it. See, we have this, the same as the carbonyl and the oxygen next to it. Then in the right side, we have another carbonyl and carbon. This is going to be anhydride. The other one is ester. Again, compare it with your carboxylic acid. You have the carbonyl group and oxygen, but instead of hydrogen, you have another carbon. This is ester. If you want to compare it with ether, ether does not have a carbonyl group. It's just carbon, oxygen, and another carbon. In ether, we don't have carbonyl group, but in ester, we have carbonyl group, which is the derivative of carboxylic acid. So make sure you make flashcard of them and practice them. Let's do naming of anhydrides. In anhydride, we can have the both sides the same. The of the oxygen is the same. You see that the left side of oxygen, we have 3 carbon. In the right side of oxygen, we have 3 carbon. So they are mirror of each other. So we can just write one side of it. It's gonna be propanoic. We just kind of get the oic part of the carboxylic acid. We keep it. It's going to be 3 carbon. So it's going to be propa, and we add oic. It's going to be propanoic. But instead of acid, we put anhydride. So it's going to be propanoic anhydride. This is when the both sides of oxygen are the same. The same here. The both sides of oxygen are the same. So it's going to be ethanoic anhydride. What about the both sides of oxygen is not the same? See, one side is 3 carbon, the other side is 2 carbon here. So we write them down alphabetically. So it's going to be ethanoic, propanoic, anhydride. Make sure that anhydride means oxygen, the 2 side is carbonyl group. Here, oxygen, two-side carbonyl group. Oxygen, two-side carbonyl group. This is anhydride. The same here. Oxygen, two carbonyl groups in the two sides of the oxygen. You see that here, the both sides are different. So it's gonna be butanoic, ethanoic anhydride. So make sure you write them down alphabetically. And for both of them, when you write the both ends, you should make sure end with oic. And also at the end, write anhydride. These are the longest chains. These are the longest chain. Let's talk about naming esters. Esters have a carbonyl group directly attached to oxygen and another carbon. This is ester, COO methyl. Let's talk about esters. The functional group of an ester is a carbonyl group bonded to an OR group. R means any other alkyl or aryl group attached to it. Here we have methyl group attached to oxygen directly. So how you name the esters? You are going to first write the alkyl group, like as a branch, before the root name. So here in the, when you look at the oxygen, you look and see what is attached to oxygen directly. This would be your alkyl group that is going to be written before your longest chain. So it's gonna be, here is the methyl. It's gonna be methyl, and I have two carbon in the longest chain. It's gonna be methyl ethanoate. When you have ester, you end up with O8. Methyl ethanoate. Methyl ethanoate. What about this one, guys? Here we have an ethyl group directly attached to oxygen. So we have ethyl, it comes before the parent name. Ethyl, and that's my longest chain. That's my longest chain. The same here is two carbons. So that's why I put ethanoate. Here I have 1, 2, 3 carbon. So it's going to be ethyl propanoate. Make sure in ethers, make sure in esters we end with O8. Whenever you have two esters in the both sides, you just make sure the same as carboxylic acids that we had, you add di before the root name. So it's going to be diethyl pentan dioate. When you have a 5-membered ester, we call it lactone. Lactone. Do you think what's the functional group here? We have a carbonyl group, another oxygen attached to it, and there is a carbon attached to oxygen directly. This is ester. I recommend you make flashcards and practice the structure of the functional groups and the name of them. So let's name it. For esters, we said that we look at see what alkyl groups are directly attached to oxygen, and we name them first. So here I have a methyl, and I know that my longest chain of carbon is here. From which side we do numbering, guys? All of guys, these carbonyl-based structures of which are derivatives of the carboxylic acid, they are always start with carbonyl group when we want to number them. So we start numbering carbon 1 here is going to be 1, 2, and 3. So then it's going to be methyl. On carbon 2, I have a 2-methyl propanoate. Whenever you want to write down the ester name, first write down the name of alkyl group, which is directly attached to the oxygen, and then write down the name of the branches with the number of carbon which is attached to it. It's going to be methyl 2-methyl propanoate. What about this one, guys? Is it what functional group? Is ester. That's the longest chain here. So it's going to be methyl methanoate. Methanoate. We end with O8 when we have an ester. Here we have the longest chain here. We start numbering from carbonyl group. So it's going to be 1, 2, 3, 4, 5, and 6. First, we write down the branch which is connected directly to oxygen. It's going to be ethyl. On carbon 4, we have a methyl group, 1, 2, 3, 4. For methyl, and we have 6 carbon in the longest chain, hexanoate. Hexanoate. This one is aromatic. We find the longest chain. Always the one that has a carbonyl is the longest chain. Okay, pay attention. Never put this oxygen part of the longest chain. That's very important. That's what I see students make mistake in the exam. Don't put this oxygen of the ester part of your long chain. Why? Because this is oxygen, not carbon. We only put carbon when we want to find the longest chain. So these 2 carbon are my longest chain. It's gonna be phenyl because it's attached to oxygen. It's gonna be phenyl ethanoate. Phenyl ethanoate. So when we have a benzene group as an attachment, we call it phenyl. Here we have a longest chain. Again, it's 2 carbon here, right? That's my what I'm going to write as a parent name. That's going to be ethanoate, right? That's 2 carbon. So what should I write here as a branch that is attached to oxygen? Whenever we have a benzene group and there is a CH2, do you see there is another carbon attached to it, and these attached to the oxygen, we call these benzyl. Benzyl. So it's going to be benzyl ethanoate. Benzyl ethanoate. Let's see how we can name these compounds. What's the functional group here, guys? This is carboxylic acid functional group. Carbonyl attached to OH directly. So whenever we have a carboxylic acid, we end with oic acid. So we find the longest chain. Is going to be start numbering from the carbonyl 1, 2, 3, 4. Is going to be 1, 2, 3. 3 bromo butanoic acid. When we are naming derivatives of carboxylic acid and also carboxylic acid, this is also true for amides. whenever we want to name carboxylic acids and derivatives of carboxylic acid like esters and anhydrides and also amides, we always start numbering from carbonyl group. And when we want to write a name, we do not need to emphasize on carbon 1 as a carbonyl group because we already know that we started from carbon group. So again, when we have an amide, ester, anhydride, and carboxylic acid, we always start with carbonyl group when we want to number it. 1, 2, 3, 4 is going to be 3-bromo-butanoic acid. Let's do this one, guys. That's the longest chain. That's the acid. So it's going to be 2-methyl-butanoic acid. On carbon 2, I have a methyl group. This one will be 1, 2, 3, 4, 5. And on carbon 2, I have a isopropyl. So it's going to be 2-isopropyl pentanoic acid. Let's do another compound. If, guys, you have a salt of carboxylic acid, like here, you have a carbonyl group, oxygen, and an ion, a positive ion attached to the oxygen. You see this formula, guys. O- plus there. O-, here, for example, Na+. You see a minus and plus in the compound. This is a salt of carboxylic acid. When you name it, you first write the name of the cation, which is here sodium. Then you write the longest chain of carbon, which is going to be 2 carbon. It's going to be sodium ethanoate. Also, you end with OH when you have a salt of the carboxylic acid, like what you did for the esters. For the salt of carboxylic acid, you also end with OH. So it's going to be sodium ethanoate.